All right, here we go. Starting with some review here, real quickly. Analyze the collision of a baseball with a bat. During which portion of the collision does the baseball's velocity reach zero? Well, when is it going to reach zero? It's going to reach zero before the collision. No, before the collision, it's still going to be moving. Whether it's positive or negative, it's not going to be zero. During the collision, well, that's a possibility because we know at some time the bat is going to hit the ball and it's going to come this way and then it's going to come back off. Well, at this point right here, the velocity is going to be zero for a moment, whether or not how much time. So this is a possibility. 1 second after the collision, 1 second after is going to have velocity, so it's not zero there. 1/100th of a second at, well, okay, that's the same thing. So obviously the answer is during the collision. It's going to come to zero and then take off the other direction. What will happen when a bullet is shot into a block of wood? Well, um, oh, we're not going to address that one, sorry. 14. A 50-kilogram wooden box is pushed across the floor with a constant speed of 2.5 meters per second. The coefficient of kinetic friction is zero point 0.2. If the force applied to the box is half, what is the resulting acceleration of the box? So right now, a 50-kilogram box is pushed across the floor with constant speed, so it's not accelerating. Right now, we know that it's at equilibrium. So what that means then is if this is my box, the force that's being pushed forward is equal to the force of friction. So what we can start off here saying then is the force of friction is equal to the force pushing it forward. Well, force of friction is mu times n, and then this is ma. Um, I'm going to find this force right now by finding out what is friction. Friction is zero point 0.2. N is m times g is going to be equal to ma. M in this case is 50, so we get 0.2 times 50 times 9.8. And it's going to be negative because it's going in the opposite direction, equals, and right now all I really care about is what the force is. What we find this force to be is negative 122.5 newtons is the force that's pushing back on it and it's pushing forward. The reason I had to find this frictional force is because they tell me if the force is being applied to the box is halved, what is the resulting acceleration on the box? Well, for me to half it, I had to find out what it was, and we said that they were equal to each other. Now, if I divide that by 2, once divided by 2, we find out that that force is equal to 61.25 newtons, and I'm going to set that equal now to ma. M's 50, so divide both sides by 50, and this is negative, that's negative. And the acceleration now is going to be negative 1.225. And the closest answer I have to that right here is B. All right, number 15. Number 15 talks about multiplication of a vector. And what we find out here when we're doing this multiplication of a vector by a scalar quantity, they want to know what happens. Well, the nice thing about that is we can go back and use our F equals ma to be able to find out what that is. Because this right here in the equation, F equals ma, a is a vector and m is a scalar quantity. So no matter what I can just put simple numbers in here. All right, force. If I put 1 in for mass, 2 in for acceleration, well, what's 1 times 2? The force equals 2, and it would be newtons. But here's what I want you to understand. Force is a vector quantity. So it would have a direction. It would be up, down, north, south, east, west. It's going to have some type of direction. So what happens when we multiply a vector, which is the acceleration, by a scalar quantity, which is the mass? Well, our resulting answer is a vector, and it's going to have a direction. So did it change the direction of the vector? No. Does it change the magnitude of the vector? Yes. Did it change the direction? No. Changes neither the magnitude of the vector nor the direction? No. Changes the magnitude of the vector but not the direction? Yes. And the reason we're saying it changes the magnitude is because we multiplied, but it's still going in the same direction. None of our math here did anything with changing the direction. And probably I didn't choose the best of numbers because I took 1 times 2. It might have been a better example if I would have taken, let's say, 10 times 2 and gotten an answer of 20 newtons. Now it's obvious that the vector did change magnitude, but the direction didn't. Okay, the next thing I want to talk about here then is equilibrium. Equilibrium can occur when? Well, equilibrium, this goes back, think about our problem back here when we had the force of friction and the person pushing forward, it wasn't going to change its speed. All right, it was going with constant speed. So this was under equilibrium because it was not accelerating. And that's what equilibrium means, is the object is not accelerating, which means it can't change velocity and it can't change direction. So what we're looking for here is an answer. Equilibrium can occur when it's not changing velocity and it's not changing direction. Constant acceleration, that would be changing velocity or direction. The exact opposite of what we want. Only a sum of the forces is 0. That looks good up here. We said that these forces had to be opposite and equal, so they would have been 0. Object is motionless. No, this up here example was constant speed, so motionless doesn't count. And only if the sum of the forces is greater than 0. Well, if I had 50 here and 40 here, if these were newtons and forces, this object would be getting accelerated to the right. So our only answer that's possible here is B. Well, hey, that's going to be enough for today. I'll catch you on the flip side.